yesterday. Okay? We're dealing with 3-7, dealing with rational functions. Yesterday we talked about two things. We talked about how to find vertical asymptotes and how to find a hole. Here's a function right here. Alright? How do we know the difference between a hole in the graph and a vertical asymptote? How about this? Can somebody tell me where a vertical asymptote is located before you even graph it? Negative 3. At x equals a negative 3, that's going to be our vertical asymptote. That's where you will see one vertical asymptote at negative 3. For those of you who weren't here yesterday, anytime you make a denominator right here equal to a 0, that creates a vertical asymptote, a vertical line that goes up and down that creates a boundary. Now you said it 4, but that's not going to be a vertical asymptote. Right here, notice these will cancel each other out. So if you can cancel out something in the numerator and in the denominator, you will have what's known as a hole where x is equal to a 4. Now if you're wondering why a 4, it says x minus 4. Well, what number would you plug in there to make that equal to 0? 4. Alright? So we have a hole right here. This lets us know because those cancel out. We have a hole there and we have a vertical asymptote. Now I want you to hit the graph button. Okay? Now, the vertical asymptote right here is at the negative 3, where x is equal to negative 3. And where did I say the other hole was? The only hole in the graph, where is it located? 4. So right here we're going to count over 1, 2, 3, 4. And if you were to draw this graph, you would need to label a hole right here at x is equal to a 4. 1 is a line. The vertical asymptote goes up and down. If I asked you to draw in a hole of a graph, you're actually going to draw something that looks like a hole. Missing point. Okay? Notice, the graph, you can kind of see the vertical asymptote. Can you see the hole in the graph? How about this? Can you see, I'm going to put zoom 4. Let's look at where it says 4. Could you see a hole anywhere? You kind of see it, right? But you know what? It's kind of hard to see. So what I want you to do, check your table. Watch this. Check your table. Notice. At 4, it says what? Error. It says error. It says error because you cannot plug a 4 into the equation. However, look what happens when you scroll up to a negative 3. What else does it say? It says error. Well, how do you know whether the error is an asymptote or a hole? That's where you have to look at the function to see, did something cancel out? All right? Which one didn't cancel out? The one that didn't cancel out will be your vertical asymptote. The one that did cancel out will be your hole. So you can't just depend on your graphing calculator to show you. Okay? The next thing we're going to cover, the main thing we're going to cover today is how to locate where your horizontal asymptote. We talked about vertical asymptotes yesterday. Today we're going to talk about horizontal asymptotes. So I'm going to pause it. You're going to make a chart. All right, so here we go. The very first example I want you guys to write down, we have 3 scenarios where m is equal to n, where m is less than n, and where n is greater than n. By the way, we're talking about exponents of power. So write down f of x equals, I want you to write 3x squared minus 4 in the numerator. And in the denominator, I just simply want you to write x squared plus 2. I want you to notice something. When I say look at your n value in comparison to the n value, our n value is actually equal to n because 2 is equal to 2. Alright? So in this particular scenario, I want you to look right here. This 3 represents your a value. What number is technically in front of the x squared? A 1. So right here, a 1 is your b value. If your powers are equal, the horizontal asymptote, right here, horizontal, is going to be where y is equal to whatever your a value is divided by whatever your b value is. In this case, our a value was a 3. Our b value was a 1. Therefore, our horizontal asymptote is y equals 3. So we will have a horizontal asymptote at y is equal to 3. So write that down, and then we're going to plug this in the graphic calculator. We're going to take a look at it. Okay? I just randomly chose a problem. All right, so what we do, turn your graphic calculator on, please. I want you to go to y equals. I need you to, whatever's in the graphic calculator for y1, clear it out. Hit alpha, y equals, enter. In the numerator, what was our example? What are we going to type in? 3x squared, and we put minus 4. And in the denominator?
1x squared plus 2, 4x.
X squared plus 2. So there is our graph right there. It's all typed in. I'm just going to hit the graph button. Okay? Now, where did I say the horizontal asymptote was going to be located?
At 3.
At 3. So what I'd like you to do, hold on, go down here. What I'd like you to do is type in y equals 3. Hit the graph. Right here, everybody, this right here at y equals 3, you have what's known as a horizontal asymptote. By the way, this graph does not have a vertical asymptote. There's no vertical asymptotes anywhere in the graph. The reason why we don't have a vertical asymptote anywhere in the graph, right here, that denominator, x squared plus 2, there's no values of x you can plug in there to make that equal to 0. It's impossible. Okay? Which means anytime, maybe you're looking, you can look at this graph right here. This right here, what I'm telling you right now, it's impossible for this to equal a 0. Because when you square a number, what's always going to happen to the number whenever you square it? It's always going to be a positive every single time. So there's no way you can plug in a number and add it to a 2 and make it equal to 0. That's why there's no vertical asymptotes in the graph. Okay? We're going to do one more example. Okay? One more example. So right now what I'd like you guys to do on your paper, go back to your notes. Let's scroll down here. You might have to move a little bit further down. Here's our second example. I'm going to write a different color here. F of x equals 5x to the third minus 4. And underneath it, I'm going to put 2x to the third plus 2. Okay? Okay. What do you notice about the m value in relationship to the n value? They're the same. All right. What is my a value and my b value?
5
and 2. So this right here represents my a value. Okay. This right here represents my b value. So if I ask you to find your horizontal asymptote, it's once again going to be a over b. So we would simply write 5 over a 2, yes, that is actually equal to a 2.5. So that's your horizontal asymptote. Now, I will say this. You will have a vertical asymptote because you can make this denominator equal to 0. By the way, I'm going to tell you guys what it is. You will have a vertical asymptote as well in this graph. So if I were to plug in a negative 1 right there, what's negative 1 times negative 1 times negative 1? Negative 1. What's negative 1 times 2? What's negative 2 plus 2? 0. That would be bad. So I bet we have a vertical asymptote at x is equal to a negative 1. If I were to plug it in right there, that would make that denominator. I'm just guessing right now. We'll see if I'm right. I'm just making stuff up. I'm not having problems. All right, so here we go. Liz, I need you to look at clear y1 out, clear y2 out, hit alpha y equals inner, and tell me what was our equation in the top. What was our expression? 5x to the 1.
5x to the third.
Okay.
Minus 4.
Minus 4. Okay, and what about the bottom?
2x to the third plus 2.
2x to the third, right arrow, plus 2. Let's see what this graph looks like. It should be an interesting graph. Wow, that's an interesting looking graph. Okay, whole lot going on in this graph. Where did I say the vertical asymptote was going to be located?
1.5.
No, vertical. Vertical. Where did I say the vertical was going to be?
It's not 2.5.
Oh, negative 1.
Oh, yeah.
Okay, I said the vertical asymptote right here. The vertical, when I put VA, short for vertical asymptote, is at x equals negative 1. Can you see how the graph's getting close to it but not crossing it? Now I said the horizontal asymptote, or actually not me, but we all said the horizontal asymptote would be at a 2.5. So hit 2.5 and hit graph,
I was right.
and there's your horizontal asymptote. Now, Ryan, unfortunately, we're recording right now, so we can go back and do a replay and realize at first you weren't right, but then you corrected yourself. So,
Oh, wait, you recorded me saying that?
right now it's recording. Yeah.
I've been waiting to be on that thing.
Well, congratulations, you finally made it. Okay, all right. Horizontal asymptote is y equals 2.5. That's how you find horizontal asymptotes when what? When when m is equal to n. So what happens when your n value is less than your n value? Your horizontal asymptote will be at y equals 0. Anytime your n value is less than your n value, that's what it's going to be. Over here, if your n value is greater than your n value, here's your answer. None. You're not going to have a horizontal asymptote. Now I'm going to give you two equations. Instead of saying y equals 0 and none, I'm going to give you two equations. Here's one of them. If I said f of x equals 1 over x minus 3, this would be a scenario where your n value is less than your n value. Now, do you see an x here?
No.
Technically, I could write it as x to the 0. And technically, this is x to the first. So therefore, if I said, what's your n value? You'd say it's 0. And your n value would be 1. So I'm going to give you a quick little test. Here's an equation, right? F of x equals x over x cubed plus 2. All right? X over x cubed plus 2. What's your n value and what's your 0? Your n value is
3.
1.
In value.
Very good. Notice you can't see it, but there's a 1 right there. I'm going to highlight it. Your n value is a 1, and your n value is a 3, which means 1 is definitely less than 3. So once again, your horizontal asymptote is at y equals 0. You're looking for the power.
I thought you said the blue was shaded.
The last scenario is when you have no horizontal asymptote, and that's where your exponent up here, the n value, is going to be greater than n. Notice in this equation, we have 3x to the power of 4, that's a 4. 2x to the power of 3, that's a 3. 4 is greater than 3, so therefore that would be none.